We're still dealing with Chapter 6, which is the right triangle approach to looking at trigonometric functions. However, we're now into section 6.3, which deals with trigonometric functions of any angle. So before we were just dealing strictly with acute angles because those are the right angles of the triangle, but now we're going to look at trig functions of any angle. So they can be negative angles, they can be angles greater than 90 degrees, and also angles like 90 degrees and 180 degrees, things like that. So trig functions of angles. So here we have a couple of diagrams of right triangles. The one on the left is just your basic right triangle that's outside of the coordinate plane. All right, so we have our angle theta, and then we have our side opposite, our side adjacent, and our hypotenuse, right? So this was theta, this was the side opposite, this was the side adjacent, and this was the hypotenuse. So now in the picture on the right, what we've done is we've converted this picture into the coordinate plane, and we've drawn this angle theta in standard position, right? So theta is now in standard position on the right, and now what happens? Our side that was opposite is now called y. Our side that was adjacent is now called x, and our hypotenuse we're now calling r, standing for radius, okay? So we just converted opposite into y, adjacent into x, and our hypotenuse into r. So what's going to happen is any point that's on the terminal side of theta can be written in the form x comma y, right? Where again, y is going to be the side opposite theta, and x is going to be the side adjacent theta. All right, and then what you can do is you can use the Pythagorean theorem. If you just go back to our last picture here, right? What's the Pythagorean theorem say? It would say that x squared plus y squared equals r squared. So what's going to happen now is if we solve that for r, we're going to get that r is just the square root of x squared plus y squared. Okay, so then what ends up happening is, since we said that y was our opposite and r was our hypotenuse, the sine of theta can just be written as y over r, right? Which was opposite over hypotenuse. The cosine can be written as x over r, which was adjacent over hypotenuse, and the tangent could be written as y over x, which was the opposite over the adjacent, right? So all we're really doing is we're changing opposite into y, adjacent into x, and the hypotenuse into r. And of course, you can find the other trig ratios in the same way, okay? And what's going to happen is we're going to be able to use this basic relationship here to find trig ratios of any angle, not just ones that are between 0 and 90. So now here's an example of this, right? So in this instance, we have an angle theta that's not between 0 and 90, right? Theta is, somewhere between 90 and 180 degrees here, okay? But what happens is we can still form a right triangle. It's just that theta is not going to be an angle in the right triangle. We're going to have this new angle here. That's going to be the angle inside the right triangle, okay? So it doesn't matter though, right? The sine of theta here is still going to be equivalent to this value here, which is our y value, divided by this value here, which is our r value, right? The sine is still going to be y over r. The cosine is still going to be x over r. The tangent is still going to be y over x. The only difference here now is we can have some negative values. So like in this case, this angle is in the second quadrant, so x is to the left, so x is going to be a negative value, y is going to be a positive value. But it'll still work nicely, okay? So if we let theta be any angle in standard position, and p, right, this point up here, is a point on the terminal side, and if we're saying that r is really just the square root of x squared plus y squared, that's going to be the distance from the origin to the point P, then the same relationship that we had before still applies, right? The sine is still going to be the y value over the r value. The cosine is still going to be the x value over the r value. The tangent is still going to be the y value over the x value. And then you can just use your reciprocal identities, right? So since you know cosecant is the reciprocal of sine, cosecant just becomes r over y. Secant is the reciprocal of cosine, so secant becomes r over x, and so on, right? Cotangent is the reciprocal of tangent, so cotangent is going to be x over y. All right. So like in this particular instance here, since x is negative, that would mean that the cosine is going to be negative because cosine involves the x value, right? So cosine is going to be negative. Sine is going to be positive. Tangent is going to be negative because tangent involves the x value. But since sine was positive, that means that cosecant is going to be positive because it's a reciprocal. Since cosine was negative, that means secant is going to be negative. And since tangent was negative, cotangent was going to be negative. So in the second quadrant, what's going to happen is just the sine and the cosecant are going to be positive values. And then if we continue looking at this, if we move into the third and fourth quadrants, we can also see what ends up happening, right? So like say we had an angle theta that was in the third quadrant. Now what happens? This point is still going to be called x, y, right? And there's your r value. But in the third quadrant, what happens is x is negative and y is negative. So in the third quadrant, sine of theta is going to be less than 0, and also cosine theta is going to be less than 0, right? Because both x and y are negative values. But then the tangent of theta, it's going to be y divided by x. So when you have a negative divided by a negative, that's going to become positive. So sine in the third quadrant is going to be negative, cosine is going to be negative, but tangent is going to be positive, right? And then if we go to the fourth quadrant, now what happens, right? Do the same thing. Let's say now this is our angle theta. And now again, this is still our point xy, and this is still our r value, right? Because again, we form in the right triangle here. But now in this case, x is positive and y is negative. So that means that cosine of the theta is going to be positive, right? Because cosine is x over r. Sine of theta is going to be negative because y is negative, right? Y over r. And now tangent of theta is going to be y divided by x. So it's going to be a negative divided by a positive. So that's going to be negative. So what ends up happening is in the fourth quadrant, cosine is positive, where sine and tangent are going to be negative.